So, before we dive right into Java, let's take a moment to answer the question, why do we program a computer? The reason why this question is so important is that it will help us put a perspective on a couple of things. First, what does programming the computer even mean? What is the relationship between a programmer and a computer? And a couple other things that will be understood by this question. So, without wasting so much time, let's just get into it and do something. So, what do all these items here have in common? Electricity, right? By the way, I'm also giving you energy saving tips. That is just by the way. So, if there is one thing we know about electricity, it's the fact that it can be switched on and off. Now, what is the relationship between electricity and your laptop or phone? It's the fact that you use electricity to charge your devices, right? So when you charge your phone, you get some battery power added so that you're able to use it. Now, here's one thing we are going to learn about electricity and laptops or phones. Inside your laptop or phone, information like pictures, music files, text files, etc. is just electricity. So all your applications, your social media information, everything reduces down to electricity on the hardware of your device. Now, in order for that to be possible though, that electricity inside your phone or laptop switches on and off, on and off, on and off, like something like that. And it's super fast. Like it's that fast. So when electricity gets treated in that way, your computer or phone or laptop is able to represent and process information. However, it's not just any random switching on and off of the electricity. There is a pattern or standard which is backed by some really complex mathematics, science, and engineering. Honestly, we don't have to worry about how that process actually works. We let the computer engineers who design the hardware take care of that. Our job as programmers is to simply program the computer. So, just a little bit of history here. Before laptops or phones or any other type of computer you know today was made, computers used to refer to humans who did all the mathematical calculations. These were people who specialized in all sorts of mathematical and statistical processes. And whenever there was the need for any calculations, it was their job to do it. For example, during population census counts, these human computers were in charge of putting the numbers together. During elections, these human computers were in charge of putting the numbers together. When governments needed to calculate the economic statuses of the countries, these human computers would do that for them. So at some point, as the human population started growing bigger and bigger, these human computers started making a whole lot of mistakes. And also, it took them so long to finish their calculations, mainly because they were mostly overwhelmed by the amount of information they were given to base their calculations upon. So, by that point in time, human computers are proven to be incapable of meeting the computational needs of the world. So it became obvious that we needed a better and more trusted and consistent way of doing calculations. So some intelligent people thought, why don't we build machines that help us when doing calculations? So they built computers like what you see in this picture. Believe it or not, this thing here is a computer. Now we don't have to worry about how these computers or these types of computers worked, but what we do have to know is that they weren't able to help us as much. As you can tell, they were difficult to use, and they also usually had many tiny moving parts that needed constant servicing in order for them to keep working. So obviously we needed something better, and by we I mean the humankind. Okay, so eventually here comes the digital computer. What you see in this picture is a digital computer. It uses electricity to represent and process information. It doesn't have many moving parts, and also it doesn't need so much servicing and attention in order for it to keep working. Believe it or not, this computer is very similar to your mobile phone or your laptop. It uses the same process of electricity being switched on and off as I talked about. So now let's talk about what's called the binary system. We will understand why we are even talking about this in a minute, but for now, let's look at the picture and then try to make some meaning out of it. I'm showing in this picture three different ways that we represent information. One is by using the letters of the alphabet. Two is by using decimal numbers. And three is by using what's called the binary numbers. So we use letters of the alphabet to write text information like words and sentences. Even though there are only 26 letters in the alphabet, the number of words we've made out of only 26 letters is over 1 million. Also, with decimal numbers, there are only 10 distinct digits, 0 to 9. But with only these 10 digits, we are able to represent almost all numbers up to infinity. With binary though, we have only 2 digits, 1 and 0, and somehow humans figured out how to represent all kinds of information using just these 2 possible digits. So here's the thing. If machines already use electricity, and electricity can only be either on or off, and binary digits can only be either 1 or 0, then binary is the most suitable method for processing information with machines. So this sort of answers the question of why we are talking about binary. Because if computers already use electricity, and electricity can only be either on or off, it has only 2 states, and binary digits can only be either 1 or 0, that one too is only 2 digits, then binary is the most suitable method for processing information with a machine. As we already know, the binary system uses only 2 distinct digits, the 0 and the 1, to represent all information. Each electrical current inside the computer that is on is represented with binary digit 1, and each electrical current inside the computer that is off is represented with binary 0. So with the binary system, since we can only use 2 digits, 0 and 1, unlike the decimal system in which we use 10 digits, 0 to 9, or unlike the alphabet system in which we use 26 characters, A to Z, we represent information in the binary system using only series of 1s and 0s. For example, A is a letter in the alphabet, but in binary, A is represented as 011000001. The digit 9 in decimal is also represented in binary as 001110001. The point is, if it's binary, then it can only contain 0 or 1. So in this picture, I show you the different ways that binary is used to show information. As you can see, if it's 0 in decimal, then it's 00110000 in binary. If it's 1 in decimal, then it's 00110001 in binary. And if it's A in decimal, in letters of the alphabet, then it's 01000001 and so on. So now let's talk about how you can program a computer in binary. So in the early days, humans had to learn the binary codes in order to use the computer. This picture shows the first personal computer. It's called the Altair 8800. The way in which you feed binary information into this computer is by manually turning the switches you see on its interface. If you need to, let's say, input 9 into the computer, and with 9 being 00111001 in binary, then what you do is that you turn the first 2 switches off, the next 3 switches on, the following 2 switches off, and then the last switch on. I hope you can already feel how it would be difficult to program the computer using binary. So now let's talk about how programming languages come in the picture. So in order to not have to use binary in coding the computer, something called as the translator was built. With the help of the translator, we can now use English-like words, as you can see here, to program the computer. The translator will be inside the computer. It is also code, and it will take the English-like commands and turn the commands into binary for the computer. Here's one thing with the translator you need to know. It can only understand specific words in a specific way. So it is not as if you just type in English letters or words or stuff like that, and it just takes it and spits out some output. There are specific words that you can give to it. So in order to formalize how we give the word commands to the translator, a programming language had to be created. So the programming language simply indicates what commands or words we can give to the translator. It also shows us how we arrange the words so that the translator can read it and understand what we are saying. So Java is one of the programming languages that we use so that we don't have to write any binary code. In the computer, there is going to have to be a Java translator to turn the Java code into binary. So now we are at this point where we can take Java and start learning how to program in Java. So I hope this content was useful. Give it a thumbs up and don't forget to subscribe.